Analyze the temperature dependence of the equilibrium constant, KEQ at 25 degrees Celsius, KEQ equals 1.3, and at 50 degrees Celsius, KEQ less than 1.3. This demonstrates that as the temperature increases, the value of the equilibrium constant decreases. Relate KEQ shift to Le Chatelier's principle. A decrease in KEQ means that at a higher temperature, the equilibrium shifts to favor the reactants, to the left. Under Le Chatelier's principle, increasing the temperature of a system at equilibrium shifts the reaction in the endothermic direction to absorb the added thermal energy. Since the reaction shifts toward the reactants when heated, the reverse reaction must be endothermic, meaning the forward reaction must release heat, exothermic. Determine the sign of delta H degrees. Because the forward reaction is exothermic, the standard enthalpy change, delta H degrees, at 25 degrees Celsius must be negative, delta H degrees less than 0. This directly confirms that option E is correct. Determine the thermodynamical favorability, delta G degrees, using the equation delta G degrees equals RT/K. We can evaluate standard free energy. At 25 degrees Celsius, 298 Kelvin, KEQ equals 1.3. Since KEQ greater than 1, the value of Ln, 1.3, is positive. Because both the gas constant R and temperature T are positive, delta G degrees must be negative, delta G degrees less than 0, indicating that the reaction is thermodynamically favorable under standard conditions at 25 degrees Celsius. The correct answer is option E. At 25 degrees Celsius, delta H standard for the reaction is negative.